In this presentation, we have to talk about time independent perturbation theory corresponding to a degenerate case. See, the degenerate system is given in this diagram. The two wave functions psi m0 and psi l0 are having the same energy level em0, so that the system is said to be in the degenerate state. The system is in the twofold degeneracy because two eigenfunctions are having the same energy level em0. If I apply magnetic field to this system, the degeneracy could be removed, which means that psi m0 is having one energy level, psi l0 is having another one energy level. So the magnetic field is acted as a perturbation here. Therefore, the perturbation removes the degeneracy. Once the degeneracy is removed, the non-degenerate system is given by this form. Psi 1 is a newly generated eigenfunction which is having the energy level E1. Psi 2 is another one wave function having the new energy level E2. Therefore, the two eigenfunctions are having two different energy levels. Now we can say the system is said to be in the state of non-degenerate level. See, come to our practical life. Before marriage, two sons, psi m0 and psi l0, are under the control of their own mother, em0. Once they got married, they are under the control of their respective wives. So, marriage is a perturbation. See, this is twofold degeneracy. Let us consider a doubly degenerate system. This is doubly degenerate system. Consider psi m0 and psi l0 to be two orthonormal eigenfunctions belonging to the eigenvalue em0. The meaning of orthonormal eigenfunctions is psi m0 is satisfying normalization condition. Psi l0 is also satisfying the normalization condition separately, which means that psi m0 star psi m0 d tau equal to 1, psi l0 star psi l0 d tau equal to 1. If you consider both the wave functions, they are mutually orthogonal, which means that psi m0 star psi l0 d tau equal to 0, psi l0 star psi m0 d tau equal to 0. Both normalization and orthogonality conditions are to be satisfied. Then only we can call these two wave functions psi m0 and psi l0 by orthonormal eigenfunctions. The linear combination of these two eigenfunctions also has the same energy em0, which means that we are combining these two wave functions psi m0 and psi l0, say in this form am psi m0 plus al psi l0 is equal to psi n0. We can get the new wave function psi n0. This psi n0 is also a solution for the Schrodinger equation. Now h psi n is equal to en psi n is the perturbed eigenvalue equation. The value of h equal to h0 plus lambda into h1. h0 is unperturbed energy level. h1 is our perturbed energy level. Then psi n is represented in the same form, psi n0 plus lambda psi n1. En is also written in this form, en0 plus lambda into en1. Substitute all these values in equation 2 and equating the powers of constant term and lambda terms. Here h0 psi n0 is a constant term in the left hand side equal to en0 psi n0. We can get equation 4. Then equating the lambda terms, h1 psi n0 is a lambda term here plus h0 psi n1, h0 psi n1 plus h1 psi n0, which is equal to, here the lambda term is en1 into psi n0 and en0 into psi n1. So we can get the equation of 5. Consider this equation 5. Just we have to give small modification. H0 minus of bring this term to the left hand side. En0 into psi n1 equal to En of 1. Take this term to this right hand side, minus h1 into psi n0. You can get equation 6. In equation 6, substitute the value of psi n0. The value of psi n0 is am psi m0 plus al psi l0. Now multiply both sides of equation 7 by psi m0 star and then integrate. See, psi m0 star h0 en0 psi n1 d tau is equal to integral psi m0 star en1 minus h1 am psi m0 plus al psi l0 into d tau. Now come to this first term. Instead of this psi m0 star h0, instead of this psi m0 star h0, we can write em0 psi m0 star, because suppose h0 is Hermitian in nature, psi m0 star h0 equal to h0 psi m0 whole star, which is equal to h0 star psi m0 star. If h0 is Hermitian, h0 star is h0. So instead of psi m0 star h0, we can write h0 psi m0 star, but h0 psi m0 star is equal to em0 psi m0 star. Using this logic, h0 psi n0 equal to en0 psi n0. Here h0 psi m0 star is equal to em0 psi m0 star. So instead of this term psi m0 star h0, we can write em0 psi m0 star. So this into this is em0 psi m0 star. Keep this psi m0 star outside. Instead of h0, put em0. So psi m0 star into em0 minus en0 into psi n1 d tau, which is equal to, say, we have to combine this term and this one. See here, take this am outside, am en1 outside, psi m0 star psi m0 d tau, one term. Just we are combining this into this, psi m0 star en1 am psi m0. Here am is a constant, we have taken out, en1 is also a constant, taken out, psi m0 star psi m0 d tau, first term. Then keep this minus sign, minus am. We cannot take this h1 outside because it is an operator. Psi m0 star h1 psi m0 d tau. Second term is over. Using this al, we have to combine en1 plus al en1 psi m0 star psi l0 d tau, then minus al psi m0 star h1 psi l0 d tau. Equation 9 is obtained. Here em0 minus en0 is a energy term, constant term, take it out. So rest of the terms are psi m0 star psi n1 d tau. This is am en1 psi m0 star psi m0 d tau minus am psi m0 star h1 psi m0 d tau. I have written all other terms as such. Say this is orthogonality condition. The product of one wave function with the complex conjugate of another wave function should be vanished. So this integral value equal to 0. This integral value equal to 0. So left hand side is 0. 0 into anything 0. See, this is normalization condition. Psi m0 star psi m0 d tau. This is 1. This is normalization condition. This integral value equal to 1. This operator we should not disturb. We have to present as such. Then this is orthogonality condition. This integral value equal to 0 because the product of one wave function with the complex conjugate of another wave function is 0. This is orthogonality condition. This integral value equal to 0. So am en1 minus am of the entire minus al psi m0 star h1 psi l0 d tau. The en1 term is taken for our account. If it is normalization, the integral value equal to 1. If it is orthogonality, the integral value equal to 0. But we cannot cancel the terms in terms of operator h1. This is in psi m0 star, this is in psi m0, okay. This is in psi m0 star, this is in psi l. We may say this is orthogonal. And will we cancel this? No, it is not correct. This is an operator form. H1 is our Hamiltonian operator, so we should not cancel, even though one is in M and another one is in L. So we may get equation 10. Just I am modifying AM En1 minus AM into this term psi m0 star h1 psi m0 d tau is written as h1 of mm, because the entire integrals is written in Brown-Ket notations as psi m0 star is presented in Bras space as m, then write down h1, then this psi m0 is written as ket of m. The entire is equal to h1 mm. In the same manner, this integral is taken for our consideration. Psi m0 star is present in Ket's Bras space as m, then h1. This psi l0 is written in Ket space as l. So the entire is written as h1 of ml. So equation 10 is arrived. Now multiply equation 7 by psi l0 star and then integrate. We can get the same way. If you do the operations, we can get the equation of this form. 14. AL n1 minus AM h1 LM minus AL h1 LL is equal to 0. Just multiply 7 by psi l0 star and then integrate. If you do the similar operations what we carried out in the earlier case, you can get the equation of form 14. Now take the equation 10. AM En1 minus AM h1 mm minus AL h1 ml is equal to 0. Take AM as a common term by the way of combining these two terms. These two terms are combined. Take AM outside, so En1 minus h1 mm into AM minus AL h1 ml is equal to 0. Now multiply all the terms with the help of a negative sign. So this first term is changed as h1 mm minus En1 into AM. If you multiply with the negative sign, this is changed as plus AL into h1 ml equal to minus into 0, 0. So 0. Now consider the equation 14. AL En1 minus AM h1 LM minus AL h1 LL is equal to 0. Now combine the AL terms. Say this is AL term, this is AL term. So En1 minus h1 LL into AL, then minus AM h1 LM is equal to 0. Now multiply the above equation with the help of a negative sign on both sides. This term is modified as h1 LL minus En1 of 1 into L plus AM h1 LM is equal to 0. To get the solutions for these equations 15 and 16, just you have to take the determinant and substitute the coefficients of AM and AL. Say the coefficient of AM in equation 15 is h1 mm minus En1. Put up this coefficient value AM. This column is having the coefficient of AM. This column is having the coefficients of AL. See this? In equation 15, the coefficient of AM is h1 mm minus En1. Yes, this is AM. In 16, the coefficient of AM is h1 LM here. In equation 15, the coefficient of AL is h1 ml. In equation 16, the coefficient of AL is h1 LL minus En1 is equal to 0. Now cross multiply. h1 mm minus En1 into h1 LL minus En1 minus of h1 LM h1 ml is equal to 0. Now h1 mm into H1 LL minus H1 mm E N1, say this term. Then minus E N1 into H1 LL minus and minus plus E N of 1 square. Then write down this term H1 LM H1 ML, entire is equal to 0. Now write down this square term, or before that just some arrangements are made. H1 mm H1 LL, take this minus E N1 term outside. You have to combine these two, H1 mm plus H1 LL plus E N1 of 2 minus H1 LM H1 ML equal to 0. Then write down this square term E N1 of 2. Then next E N1 term minus of H1 mm plus H1 LL, entire is multiplied by E N1 plus combine these two terms, constant terms, H1 mm H1 LL minus H1 LM H1 ML is equal to 0. This is in the form of AX square plus BX plus C equal to 0, quadratic equation. Here X square A equal to 1, X square equal to En1 square, B equal to minus of H1 mm plus H1 LL. Then C equal to this term, these two terms. This is C. Just to substitute the solution, X equal to minus B plus or minus root of B square minus 4AC divided by 2A. X square is equal to E N1 square. So E N1 is the value of X, equal to minus of B. Already B is in negative, so minus and minus plus H1 mm plus H1 LL plus or minus B square. So this term square minus 4 into AC, A equal to 1. Then C is this term H1 mm H1 LL minus H1 LM H1 ML whole divided by 2. Then we can get two solutions, En1 of 1 and En2 of 1. En1 of 1 is H1 mm plus H1 LL plus the terms available inside the root whole divided by 2. Then En2 of 1 is H1 mm plus H1 LL minus the terms available inside the root whole divided by 2. Therefore, the original energy level is split up into two compartments due to perturbation. The new energy levels are Em0 equal to Em0 plus En1, and another one is Em0 plus Em0 plus En2 of 1. This is another one energy level, which means that before perturbation we are maintaining the degeneracy in this level. This is psi m0, this is psi l0, this is Em0. Now after the perturbation, see, this is psi m0. The energy level is, or we may write this one as a new wave function psi 1 to know the perturbed wave function. Say this is psi 1, the new eigenfunction psi 1. Then the energy level of this psi 1 is Em0 plus En1 of 1. En1 of 1 means take the positive root. Then another energy level is, another wave function is psi 2. Then the energy level is Em0 plus En2 of 1. So in this way the degeneracy is removed. The removal of degeneracy is possible with the help of perturbation. Suppose the two roots are having the same value, En1 of 1 is equal to En2 of 1. We have to go for higher order perturbation, which means that we have to go for the comparison of lambda square terms. Thank you.